Hello, thanks for coming to my talk. My title is Leveraging AI for Recruitment Towards Economic Recovery. Before jumping into the good stuff, I'm just gonna introduce myself quickly. My name is Keisuke Inoue. I'm a lead algorithm data scientist at PandoLogic. 3 quick fun facts about me that you can't find online or LinkedIn. First is I still use iPhone 7. I'm actually not great at keeping up with new technologies outside the work. I even ride a bicycle to work, the stuff that you have to pedal to move forward. And second, my favorite ramen is tonkotsu by far. And I have a list of tonkotsu places in New York City. If you have any questions or even better recommendations, please let me know. I'll be happy to hear. And third, when I was 12, I think my career goal was to be the professional Super Mario Brothers player, and I was really on the right track. But moving forward, in 2021, I have less fun job, but equally exciting, maybe, and definitely more important job at PandoLogic now. And that's a segue to talk about what we do at PandoLogic. So PandoLogic is a programmatic job advertisement platform. What makes PandoLogic great is that they are the only one in the industry to fully automate the process. So the distribution and optimization of the job advertisement. And it grew rapidly, especially over the COVID time, to the point which we received multiple awards, but most recently we got Gold Award for Best Technologies to Combat and Reduce the Impact of COVID-19. So COVID-19, I'm sorry. And it's such an honor to receive such a thoughtful award, after all these 2 years. Meanwhile, I myself has been working at New York City startup called Wendy. I joined Wendy just before the COVID time. And what we had been doing was to build an AI chatbot to recruit people, to conduct recruitment interviews. And just recently, PandoLogic acquired Wendy and became one family. So this was pretty much, I think, the marriage made in heaven, where PandoLogic provides the scale and AI to find talent, whereas Wendy uses AI to improve the engagement and experience in HR process. So that's our company. Just going back to the context of COVID, it's not ended yet, right? So what makes me sad the most about this COVID is you drive through the town or city and you see all those signs that is hiring, or we are hiring with even sign-up bonuses. What's happening is this labor market remains sick, even after 2 years with this virus. Clearly, employers everywhere are struggling to find best talent and adapt to the post-COVID environment. Clearly, we are facing an enormous recruitment challenges. The COVID has essentially turned the world upside down. And according to our ATS partners, during the COVID, we saw job openings increase by 35%, but job applications actually went down 20%. So the road to economic recovery is really complex. So today, I'm just going to go over one of our technologies to support the economic recovery, which is Wendy. So here you go. Let's meet Wendy. So Wendy is an AI recruiter, which performs these key 4 HR tasks in the recruitment processes. One is to identify job requirements from job descriptions, and then design job interviews. And 3, execute job interviews. And 4, evaluate candidates based on the responses in the interviews. And under the hood, we implemented 4 different services to handle each task. So NLP service to parse the job descriptions and extract the job attributes, and chat generation service to use that job attributes and generate that chat specification of the chat. And then chat API service that is connected to a platform called Kore.AI, Kore.AI, to execute the interview. And finally, evaluation service to evaluate the candidate. If you put these 4 services together, it looks like this one big function where on the left-hand side, the job description is the input, and on the right-hand side, the output is the evaluation of the candidate. And in between, we have these 4 services, and which utilizes different machine learning models and NLP processes. Note also that we use graph database to persist all the entities or intentions or skills, etc., to persist all those entities in our database. Before moving on, I'm just going to show you a quick demo of our service to give you an idea. So here on the left-hand side is a chat platform screen, and on the right-hand side is our graph database. And I would like you to look at this right-hand side screen first. The first one, this node represents an application. The application means it's a connection between the job descriptions and applicants. And it has this chat generated from our system. This is actually my favorite demo. So this is a warehouse position, and look at this applicant. His name is Samit. It's actually my CTO, my boss, who is applying for warehouse position for whatever the reason. And so far we know this his location, his email address, probably fake, and his LinkedIn profile, and his phone number. I really hope this is fake. But once we start interviewing him, we will enrich this profile. So that's what I would like to demonstrate. So going back to the left side, I'm just going to restart the chat. So the Wendy says, hello, I'm Wendy, the AI recruiter, and then say, thanks for your interest at warehouse position at Wendy demo. Let's kick things off. Sounds good. So ask for elevator pitch. I don't know what to say, so I just paste this sentence. How many years of experience do you have in warehousing? So I say 10 years. And tell me, where have you worked? I'll say I was a warehouse worker at Walmart. Not my CTO didn't do that, so it's all just hypothetical. Let's give it even. Tell me 2 main responsibilities. I really don't know what are the responsibility as a warehouse worker, so I'm just gonna say warehousing in general and IT operations. All right. And it says, do you have experience in accounting? Okay, I'll say yes. And then could you tell me more? Well, actually, I don't know much about accounting, so I'm just going to stop the demo here. But we're going to the left side again and look what our system learned from this conversation. So just close the node and reopen it. And now we see a little bit more nodes. So the new nodes is these, right? So now we know Samit has experience of 10 years. And also, his experience was at Walmart and as a warehouse worker. And you can also say he also has a skill of warehousing, and he has common skills that is specified between by the job descriptions. So these like common nodes will be evaluated highly, while these skills are still, if they are relevant, evaluated later, right? So you get the idea, and I'm just going to go back to my slides. Now I'm going to talk about 4 machine learning models that we use to extract job attributes. The first one is called complexity prediction, and namely it predicts the complexity of a job based on different aspects, such as title, type, seniority, skill, expertise, and location. And this is used to set the expectation of our clients in terms of time to fill. So for example, junior warehouse worker in Seattle is probably easy to find, so it has a low complexity, while finding senior Scala engineer in Winnipeg may be harder. So for this model, we use simple regression model that was trained internally. I'm gonna skip all the details about the design of the experiments. It's been talked in different conferences. But what we typically do is we do a comparative experiments, including classic models and transformer models, mostly using like Spark NLP library or Hugging Face transformer library, and then compare the performance. If the classic model wins, we take it because it has a much smaller footprint, easy to deploy. But if the transformer model wins, we try to match that performance with classic algorithms. If we can't, we try to adapt to deploy the more complex model. So that's the approach that we generally take. And in this case, a simple regression model worked. So that's what we are using right now. The second model is skill extraction. And this is the most critical, and it's probably the hardest one in this process. So skills are critical because in order to conduct a good interview, we need to know what kind of skill sets we are looking for. So for example, if the job description says recruiter, and we may want to hear about candidate screening skills or sourcing skills or interview experience or experience with ATS systems. Whereas if the job is about senior data engineering, the skills that we may be looking for could be Spark, Scala, Java, etc. And for this process, we actually used to use a third-party API service called Daxtra, and they've been doing this for years. They are actually doing it for over 20 years, parsing job descriptions and resumes. So they do this job very well. But now that we have been acquired by PandoLogic, the PandoLogic has its own in-house model called job taxonomy that maps job descriptions to skills and education and certifications and so on. So we started using this. I said this model is most critical and probably the most difficult one. And I just want to show you a little bit about that, which is skills are really, really messy. So for example, if I look into the database we have a database of 350 million people's profiles. So you can pretty much imagine like scraped LinkedIn of all North Americans, right? Like including Canada, Mexico, US. And among those 350 million people, there are 9 million different skills, 9 million unique skills. And imagine that with comparing the number of entries in Oxford Dictionary. That's a huge dictionary, which has 350,000 entries. Or in English Wikipedia has 6 million entries. So I would assume, given these numbers, like any word or phrases in English you can imagine is a skill. It's something that someone lists as a skill. That's my hypothesis when I was creating this slide, and I needed to test my hypothesis. So I did. My first random word that I came up with was banana. So banana or bananas. So I went into Elasticsearch and counted the number of people who lists their skill, who lists banana as their skill, right? And meanwhile, while I'm at it, I did it just for the heck of it. I did oranges and apples too. So I counted them all. And since we're here, if you have any guesses, please put some comments, like which one is the most popular skill and which one is the least popular skills. Okay, so here are the answers. Banana is 42, orange is 144, and apple is 140,000. So you can see that because apple probably is meant for any skills related to software or hardware that is relevant to Apple computer, right? So for some reason, people just say Apple. And they may mean they have app development experience in Apple, or they can fix Apple computer, and so on. So in any case, you can see that the problem of synonymity is already here. The apple can mean different things. And more importantly, for Douglas Adams fans out there, we now know the ultimate question of life, the universe, and everything, right? How many people list banana as their skill? Answer 42. All right. Moving on, I wanted to come up with another random word, so I did. Unicorn. Just note that I have an 8-year-old daughter, so my TF-IDF vector is skewed towards that kind of demographics. So while doing unicorn, I have to do panda and cats. I don't know why, but I think I had to, so I did. Again, if you have any guess which skills are most popular, which skills are least popular, please feel free to comment. You ready? So here we go. Unicorn is about 3,000, panda is about 9,000, and cat is about 56,000. So you can see that panda is higher than unicorn, more popular than unicorn. And I hope you guys are guessing because pandas is a data science library in Python, right? So people actually put pandas as their skill. And cats are very popular for many different reasons, but also CAT is a very common acronym, and probably most popular one is the CAT scan, right? The computer assisted tomography, right? Or CT scan. So CAT is a very common acronym. Again, you see that what makes entity recognition harder already here, acronyms and synonyms. Just these two simple examples. By the way, also there are a lot of fictional skills too. Like my CTO found people who list zombie hunting as part of their skills, and there are over 100 people who list there. So if your company needs to be ready for apocalypse, please feel free to reach out to me, and I think I can find the right talent for you. All right, moving on. More skill-related model. This one is called skill recommendation, which suggests skills from job descriptions. But for this one, we use this model particularly for job descriptions that do not provide enough information. The examples are the same, right? The recruiter have these skills. I want recruiter to suggest these skills, even if job description doesn't say these skills. We may want to ask these Spark, Scala, Java skills, even if the job description doesn't talk about it. If the job doesn't talk about it, right? And for this one, we use clustering and ranking. We cluster job descriptions based on the similar job titles, and then rank the skills based on the frequency, and then suggest by the ranking. Why do we need to do it? Again, there are some job descriptions that are not very informational. And I give you some examples, some real examples from our actual database. First one is EHS staff nurse, New York, job description, help with administering COVID vaccinations. So that sounds like a very important job, but not much information here, right? Next one, nuclear medicine technologist, job description, ideal candidate. Yeah, we get that, but it's still not helpful. And last one, associate financial consultant, job description, see job description, recursive. It's very clever, very, very clever, but it's not very helpful. So for these kind of job descriptions, what happens is our wonderful ops team jumps in the call with clients and get alignment, right? So these are the skills that we think we should ask during the interviews. Are they okay? And our model we want our model to help operation team to come up with good suggestions for these types of job descriptions. Right. Lastly, it's a very simple model, industry classification. It's a simple text classification model that classifies job descriptions into one of 50 industry-related categories. And it's used in the years of experience question that you saw earlier. Wendy often asks you, how many years of experience do you have in blah? The blah could be sales, healthcare, hospitality, retail, marketing, etc. So because we want to evaluate the candidate's experience within that related industry, we would like to use this model to classify the industry based on the actual job descriptions. Oh, so the example here is nurse is healthcare, of course, architect is architecture, of course, and so on. All right, just to quickly recap, what I explained for now is these 4 models that are used in this job attribute extraction. So once this job attribute is extracted, we know all the information to generate a chat. We pass this information to chat generation service. And what chat generation service do is to generate a chat using a template. So template means it's a combination of hard-coded text and variables. And these variables are replaced by real values while chat is generated. By the way, we are also working on picking the template automatically, and we are currently picking the template based on the industry and company names and job titles. So once this template is created, for a chatbot, it's a simple task to execute the chat, right? So the chatbot, the structure of the chat is very simple. Basically, when it starts the chat, it retrieves the chat data from the API, select the first utterance, speaks the first utterance, receives the response, saves the response, moves to the next utterance, and so on until it reaches to the end. However, this is very directed conversation, and it's almost like it's a form filling, right? It's not natural. It's not interactive. So we have a mechanism to make it more natural and more interactive called interruptions. So interruption is something like this. I'll just give you an example here. So Wendy asks a question at the beginning of sourcing chat. It's a typical question. Are you interested in this role? So making sure the candidate is interested in this role before moving forward. We are, of course, expecting yes or no answer here. But sometimes candidates say, where is the job located? What's the salary range? How big is this company? Basically, the candidate wants to know more about the candidate, which is very reasonable, right? So there is a handy mechanism called Interruption on this chat platform that we are using, Kore.AI. We can set intent detection in every response that our candidate or interviewee makes. So we run entity detection. Entity detection detects this question, then we generate a response. And we can use the same template approach. In this case, we can respond with the location that is available from our API and embedded as a metadata in our chatbot. So once this question is handled, we move back to the original dialog flow. So that's what we are doing. So now going back to this flow of the chatbot, I showed you a quick, simple loop, one loop. But with interruption, it just became actually just a single, became additional loop that is handling the interruption. And lastly, quickly on evaluation, our evaluation is using a causal network, which means basically a combination of or chain of conditional probability that represents the weight of the data points. In our case, data points are gathered from the responses and in 3 groups. One of them is skill, and then responsibility and knockouts. The skills and responsibility have their own weight that we can adjust, and knockout has a fixed weight which means 0 or 1. So for example, if any of the criteria, salary range or employment type or visa status doesn't match, the candidate does not pass the evaluation. Whereas skill or responsibilities, it's a numerical value that is adjusted by these weights. And as long as the overall value goes over the threshold, the candidates can pass. So that's how evaluation is done. Okay, so I just scratched through the surface of how NLP, AI, and machine learning technology works. But the more important question is why we do it, right? We go back to the first question. So we do this because finding talent has become enormous challenge, and the challenge is never ending. So our technology, with our technologies, employers can find the talent quickly through programmatic platform and then qualify these candidates through conversational AI. Ultimately, at the high level, not filling open jobs blocks growth of the society at most basic level, right? Like restaurants cannot run efficiently, and packages aren't delivered on time, and grocery stores, you can't find your favorite cereals in grocery stores, and the list goes on. So our mission here is to help employers who are in need for the talent and people who are in need for jobs find each other in the most optimal and pleasant way, right? So that we quickly rebuild our society back together. Okay, that's it. Thank you so much for your time today. I hope you enjoyed my presentation, and I hope you enjoy the rest of the NLP Summit. Thank you.